turn now for last technical presentation. So while I'm speaking and presenting here, prepare your drinks, cakes, cookies, the good mood for the party. Let me share the screen and started. I think you see it. Let me make it full screen. Okay, this looks pretty good. So the last presentation and my second of this event. If you want to learn a bit more about myself, please view the first presentation I did it at the beginning of the day yesterday. We'll make it available soon on YouTube, as we are preparing to cut it per session. So I'm no longer spending now time to introduce myself. If you haven't seen the session from yesterday, I'll be also available during the party session if you have further questions about myself. What I'm gonna present now is about using the Kamailio with the two frameworks for configuration file, our native configuration scripting language, and what we have added no longer that recently, being pretty a few years ago, like 4 or 5 years already. This what we refer to it as KEMI framework, which comes from the Kamailio embedded interpreter interface. A few words about this KEMI framework. Practically, I introduced it first for the version 5.0, and it came as a natural evolution. So the native scripting language is with the project from the very early beginning. Again, yesterday in my session, I had the timeline, and the project started in 2001, SCR, OpenSCR, all with this native scripting language, which evolved over the time. The presentation so far showed variables transformation, snippets of config file, this scripting language from Yufei or Andreas, or and in Fred, you saw many examples of this. However, the world has evolved pretty much since 2001, 2002, when the project was initially designed and developed. And lately, it's a lot of integration with external, with third-party systems, such, API servers, or NoSQL backends, whatever you can imagine, and cloud services. And our scripting language was designed mainly for routing SIP traffic, analyzing it, updating the content by remove headers, adding headers, do accounting, what's somehow specific for the VoIP service. But we know is no longer the case these days. Obviously, one could say, but why not extending it for, having connectors for everything out there to be able to integrate with this backend system or cloud services. That's one way to do it, but also I have to think that Kamailio main purpose is not developing another scripting language with a lot of libraries for everything not related to SIP, but actually be a very fast SIP routing engine. And for this special needs, the solution I was thinking about was allowing to write this routing logic in other scripting languages, which come with a rich baggage of their own extensions, like Python or Lua or Ruby. And we have also some that could be easier embeddable, like JavaScript engine is not Node.js, just to clarify it. It's an external project, but which is embedded in Kamailio, so it doesn't depend on an external library. It comes out with the Kamailio module that offers the JavaScript interpreter for our configuration logic. From the past, we still have some other embedded interpreters, but they were not updated to implement this KEMI interface. I'm speaking here about Perl and .NET. We have AppMono and AppPerl that could execute pieces of Perl or C# code, but you can't really use them as a KEMI interpreter. You can use it as inline execution, and I will see it later in the slides, these two variants. Then extending Kamailio configuration file will require a C developer and a little bit more than that, because I have to play with languages like Flex and Yak. So it's about building a compiler for our interpreter. So adding new tokens for the core interpreter and so on is not only C. Nothing very sophisticated, but many they haven't used it so far and find it a little bit strange from this perspective. Besides that, we know that these days not so many programmers come into the C language space. Many coming out from the university go for studies, high school go towards web programming, Node.js, Python, Golang. So the idea was to attract eventually such developers also in our project. Here, just to refresh a bit, Henning actually did a good introduction and overview of the config file as well. So practically, as we're designing scripting language from scratch, we could decide what are the keywords, what are the meaning of special blocks. So we define like a request route block, like function executed every time a SIB request is received. So like a main function for handling the SIB request. Then we have the equivalent for SIB reply, SIB responses, this reply route, and then somehow event-based routing blocks, like if sending a transaction out failed, we have the failure route. If you want to do per branch processing, so sending a request many times out, and you want each of these outgoing branches to have different headers, to have different destination and so on, you can tune these attributes using branch route. And quite a lot of event route, which are specific per module, exported by the needs of that module to be executed on different situation, like call started by the dialog module, or dispatcher gateway it's down or back up. You can get these event route blocks executed from your configuration file. Now, if we look that we have a full control of our interpreter, but then every new extension requires C code exporting the function to the interpreter and so on. When we go to the KEMI side, we don't control the interpreter anymore. We don't develop the Python interpreter. We don't have access to it, like commit rights for the repository, Python Lua, also this JavaScript interpreter, ducktape, or the Ruby interpreter. We have no control. Of course, they are open source and we could eventually contribute, but we have to rely on what those interpreters offer. So now what we had as a keyword, they cannot really propagate in the same way and the same prototype or format. We have to leverage their function definition. What we could do was choosing like explicit names in that scripting language, as we have as an equivalent to our routing blocks names in the native scripting language. So practically, For request route that we have in our native config file, in, for example, Lua, you have to define a function KSR request route, and Kamailio will execute that route function, function in the Lua script. Will be the same in JavaScript or Ruby like equivalent. And then for these routing blocks like repair route, onsen route, we have predefined names. For the other routing blocks that we have in the native scripting language, like branch route, on repair route, event route, this can be set actually through some parameters of other functions, because also like execution of a failure route happens in a native config file if you ask for it with like T on failure. This function is also available in the Lua script, and we have KSR TM T on failure, and now the name is the function in the Lua script, as opposite in the native scripting language, T on failure will get the name of the failure route block in native scripting. So it's pretty much one-to-one equivalence on the core routing blocks, and then choose your name as you choose for the branch route or failure route. Choose a function name in your Lua, Python, Ruby script, and so on. You have also the example like a route zip out on the left side, which is native scripting, and then on the right side would be the equivalent, which is like a Lua function of the same block. So also is, you see, we try to map on similar naming for this action or function. In the native scripting, we have our predefined tokens for like URI and myself. We couldn't do it in the Lua, but we export it as a function with equivalent behavior. KSR is myself URI. Appending a header. In the Lua, we work object-oriented like, so we have the KSR as the main module. We export, so practically Kamailio becomes the Lua interpreter and makes available as a core library in this custom Lua interpreter the KSR module. And then you have sub-modules specific for Kamailio module like KSR TM, KSR CoreX, and the functions exported by that module. You have to be careful with the exit behavior. Again, in the native scripting language, we control the behavior. As we get the exit, we stop the execution of our config script for that zip message. If you do exit, like the exit Lua function, that means stop the interpreter, and the Kamailio is the interpreter, is like a system exit. So Kamailio will stop. We export another function, KSR X exit, that simulates the behavior of Kamailio exit. So it doesn't stop Kamailio, but stops execution of the Lua script at that line. We have some links here if you want to see like more complex examples. You have the link to the Lua, but there is also for Python, Ruby, JavaScript, like complete examples of routing blocks written in these languages, and also the link to the API function that we exposed to the KEMI framework. From performance point of view, because this was a question and the past events I've been presenting about KEMI. I haven't done it recently, but I don't expect major changes because this was done for Debian 10 and recently Debian 11 was released. Otherwise, Debian 10 shipped with the same Lua and Python interpreters for the test I did in this and present in these slides. Practically, you don't really get any performance penalty if you have this one-to-one translation of the native configuration routing blocks to, let's say, Lua or even Python. Python, surprisingly, was really fast, more than I expected. Lua, because it does pre-compilation of the configuration file when it loads. Sometimes it's even faster than native configuration file, because also in native configuration file we have a little bit of pre-compiling, which we call fixing up. So we see there are variables, and then during the runtime we evaluate the variables, and then we execute a common C function, which is executed from the native interpreter, and then it's also executed from the Lua module that internally is the Lua interpreter for the routing script. So here are some details about the system. If someone wants to try, there is a link to the wiki where you get more details. I'm just showing quickly the numbers for Lua and Python and the native. As you can see, the average execution in microseconds, it's pretty much similar. I choose one that somehow shows Lua being better, but in long run, practically there is no difference. Like seeing here, a few microseconds makes no real difference. And as I said, Python was surprisingly good, probably with the new interpreters after Google invested a lot into the language and the interpreter. The results were way better, because a few years ago, before this test, I did it with the older interpreter, and the results were not as good as this one. But it's just to clarify it quickly that from the perspective of the performance, when executing Kamailio functions like this T-relay via native scripting or via Lua or Python, it's the same kind of performance. Now, of course, in the Lua and Python, you can import external libraries, external modules, and then if you execute function from those modules, it's a matter of how good they are implemented, how much they, I don't know, block for DNS or other operation, but that's out of control. It's something that you get access by taking it from somewhere else. It's the performances here, we're focusing on executing the same Kamailio function via native interpreter or via the Lua. The summary, I don't want to go much over because you can read more in the wiki. Again, it's mainly to ensure everyone that this Lua interpreter or KEMI doesn't affect the performances of Kamailio, knowing that Kamailio is regarded as high capacity and everyone wants to keep it that way. Going on to the main topic of the presentation, I'm starting with the config file being written in the native routing language, scripting language, and then how you could do inline execution of KEMI functions. If you look at the interpreters that we have for KEMI, like Lua, JavaScript, Python, or Ruby, they export a function for native configuration file, typically having a run in the name, like Lua run, Python, it's exec because it was an order before the KEMI. Then we have GSDT from JavaScript ducktape run or Ruby run. And then you can pass as parameters a name of the function in a file that you specify as a mod param to the respective interpreter. So for the app Lua, you have to say via mod param load this script and the path to the Lua file. And then in the request route block or in the on reply route, you can execute parts of that Lua script. I gave here an example with the JavaScript to show something which actually it's quite useful, and I have it running in production. As I said, the JavaScript interpreter, it's cloned in our module. Doesn't depend on any external library. It's automatically compiled with Kamailio core, so it's a very convenient way of using it when you need something more sophisticated that maybe Kamailio configuration file doesn't offer, or if it offers, makes it too complex to do it with our actions and operations in the config file. So what's the idea here? Practically, it's about getting a JSON, and here it's like this RTJSON module document format. Practically, it's getting a list an array with destination. For each of these destination, we have a couple of attributes, what to put in the request URI, outbound proxy address, how to change the headers. But at some moment, I got this request where, with integration of these cloud services, monitoring, I don't know, media gateways and so on, every now and then, this overlay monitoring tool was generating a file on the file system with this routing out, but they wanted to generate it once an hour or maybe even once a day, and then randomize it, because they had inside, like, I don't know, 20, let's say, media gateways, and they wanted to try the first 3 or 4, but in the randomized mode. Now we have in Kamailio JSON modules that you can parse, extract values from the JSON, but then randomizing like objects in the structure, in this JSON structure, and then also stripping to keep only the first 3 could be something really complex to do in the configuration file. On the other hand, JavaScript works natively with this JSON. It's practically JavaScript object format from that perspective. So what I did, I wrote a small function which is on the right side. So KSR RTJSON rand, and I'm passing this parameter, the JSON document, actually via a variable. So with the file read, I read from a text file into the variable JSON, $var JSON, and then I just call with JSDT run the function ks_rtjson run. Again, this is placed in the etc Kamailio lib.js, provided as a mode parameter for app JSDT module. And the function, it's not really complex. We have ksr_pv get the variable value, and then we parse it with the JSON function object from the JavaScript, and then we iterate to all the route blocks and we randomize it. So that's the script there. And at the end, I'm stripping the length to 3. So I'll have only 3 objects that will be used this route for sending out. And then is the usual RTJSON init routes and push routes. These are part of the configuration file I had at some point. I think it was a KruCon or AstriCon where I presented about the RTJSON a little bit more, so you can find it in the archive, or ping me if you need to read to get more about it. So practically, now I combine the native scripting language with something that I could not do that easy in the configuration file with our scripting language. It's a simple example, but somehow useful. As I mentioned, no need for external libraries. JavaScript interpreter, it's embedded in app JSDT module. And then you get also benefits of ability to reload. So if I change the file Kamailio lib.js, I can reload it without restarting Kamailio. This is another feature that comes with the KEMI interpreters, reloading the scripting files without restarting Kamailio. The other way around, so we go for routing blocks actually being functions in the KEMI language, and we want to actually be able to call some route blocks written in Kamailio native scripting. As I said, practically when you use Kamailio with Lua as a KEMI interpreter, inside Lua you get this KSR object, or like a library. And from the core of the Kamailio you get ksr.route, and the parameter is the name of this route block. As we exposed also most of the function from the other modules, the CFG utils had this function already, route if exist, and that was for native config file. And if I'm not wrong, Ole added. So the purpose for that function was initially developed and used in our native scripting language, but then we exposed it also to KEMI interpreters, and you can use this one, KSR CFG utils.route if exists and name. So practically, if that route block is found, will be executed. So any of these two variants you can use. So from Lua or from Python, you can invoke blocks that you write in the configuration file. So just to have it as a reference, currently, as I counted, there are over 1,100 functions available in the KEMI interpreter exported by Kamailio to them. Well, you have to be a bit careful, and I'll have a few more slides about this, let's say maybe little traps. Now that you write some parts in the native scripting language as route blocks, you may be willing to use this exit or drop to signal I don't want to continue for processing of the config file from now on, or I want to drop this reply. Practically, it doesn't happen anymore. Again, the interpreter for the routing language, it's Lua Python. We can't really control it from our interpreter directly, but you can either rely on the return code of the KSR route. So in case of exit drop, that should return 0, or actually you can leverage these variables that you can set in one or the other and check it from the other one. So here we have on the left side, again, like Kamailio config, which even if you use KEMI scripting, the module parameters, the core parameters, loading modules is still our native format. And then we say CFG engine Lua. So instead of calling request route for incoming request, we'll execute KSR request route from the Lua script that it's passed here via load mode parameter. So practically now you can still define after CFG engine Lua route blocks with name, like we have here route RM headers, remove headers. And for the sake of the example, I gave here how you can pass information back to the Lua script that you want to exit. So if it's method option, I send the reply, I set the variable exit. So all this native Kamailio config scripting, and return. And practically in the KSR request route from the Lua script, at some point we have this KSR.route with the name of the route block RM headers. After that, I get the value of the exit variable, and if it's 1, means, okay, from my route block RM headers, I want it to exit, and I call the KSR X exit and end. In this route block, again, more like an example, it's using the remove headers with some list of headers here as I choose for the example here. Why this could be good sometimes, it's in our interpreter with this fix-up mechanism, we detect like it's a common header, and for some of them we have optimization like p-asserted identity authorization, proxy authorization, and the parsing of the parameter it's done only once at startup, and then during runtime we use some internal value to see if it's that header or not. So we don't really compare anymore as a string for the runtime. Of course, the parser will do it once, and then we'll set the type of the header. But then remove header field will use this integer ID comparison. Again, this is something that it's more, for example, how to do it and how to pass information from one interpreter to another. Where I use it sometimes it's for logging, because with Xlog, you have a more compact format. You can put variable directly in the parameter of the Xlog, Xerror, and so on. While in Lua Python, you need to get the values of those variables and then pass it as a string to KSR, Xlog, or Xerror, and Xinfo. So there are different use cases which this combination could be useful. Now, I said I want to make a few more remarks about some tips and tricks. It's working either way, no matter you use native scripting as the main one or KEMI scripting as a main one and inline execution of one or the other. Look at or where you have to be careful would be with variables, because in Kamailio native scripting, we pre-process these variable names at runtime, and they become as a single object or memory space in the interpreter. Now, in the Lua or Python, you can also define variables, but now the interpreter, like Kamailio native variables, by using this KSR PV get set, behind that variable object has to be created by our Kamailio core. But be careful not to define many with dynamic name in the way that you practically create a lot of variables, like var x it's one, var y it's another, var z it's another, and if you keep adding like different variables from the Lua Python, is like dynamically defining these variables and somehow filling the memory of Kamailio. Then sometimes if you use it in a couple of places, it's good to fetch the value of a variable from our native scripting language to your KEMI interpreter scripting and use the KEMI scripting local variable for other operation. Like I have an example here, getting the user agent into the local k_ua and using that Lua variable for string find as a function. So you can push it into a local variable in Lua, Python, JavaScript, and use that for better access. Of course, you have to be careful that if you, for example, get the value of the request URI, but meanwhile you execute like lookup location or other function that updates inside Kamailio, you'll have to retrieve it again because the local copy is not directly linked, it's not a reference, it's a clone of the value. Because again, the focus is on variable because most of the config files in the native scripting use them extensively. Look now at Kemix module, and I still have another slide about that because it tries to facilitate working with functions for getting attributes specific to Kamailio runtime instead of using or leveraging the KSR PV get set functions. So I added there, I think there are over 60 right now. So you can get the request URI username, domain part, the port, all this equivalent of $RU, $RD, also from header user domain, the full URI there, source IP, destination IP, this which are most common, or from my point of view, were most common from my config files I did so far. You are welcome to contribute, of course. If you have a variable that you use, you can make a corresponding function in the KEMI, and we will gladly accept it. Otherwise, don't be that much concerned about performances, because we also do caching of these variables and we optimize it even if you do it from Lua Python. It just sometimes looks more native in Lua and Python to use a function rather than, you know, PV get and you give like $UA, or you can use a function get user agent, and whoever reads that Lua or Python script feels it's a bit more native, or better integrated in the structure of Lua and Python as designed. Then different modules also export now functions that in the native scripting are equivalent of operation with variables exposed that by those modules. For example, hash tables. Typically in the native config file, you work with $SHV, SHT, Here you have functions to set the value, get value, and you provide the name of the table you want to access, the name of the key in that table, and then you can provide the value and expire at the same time if you set it, and so on. Then also PV offers a lot of functions to KEMI interpreters to operate easier with XAVPs, XAVPs U and I, the new variants that we have now. Corex modules also offer many functions that correspond to maybe core keywords or core functions. Again, you have the link here for the function we exposed to interpreters. A few words about the Kemix module, as again the name also suggests KEMI extensions. Just to highlight a couple of its characteristics, mention about these relations somehow with the variables from the native scripting language. And then you may see these three variants of getter function get, and then you can have like source IP or RURI or request URI user, and many of them have this get E, and get W. The one it's more or less one-to-one mapping to the getter function that sits behind the variable, in the way that you can return its int or integer or string value or null value, this $null equivalent from the native scripting language. But then with some languages, if you try to do operation like with Lua, if you try to do an operation with a nil value, you may get some like an error and fills the logs or rise an exceptions and so on. And then we have this get E, which it's giving the value if it's set to int or integer, or will return an empty string, which sometimes could be more convenient when doing a search in the string or when concatenating that string. And get W is the equivalent of getting the null for printing. If you do printing of a variable that has null value at that moment with xlog in Kamailio native config, practically you will see this null string between angle brackets, and that will offer the equivalent of that. And you have some example here, like what you could do with this function, like getting the user agent, and with the three variants to compare it with nil in Lua, or check the string if it's greater than 0, or printing it and see it was a null inside the Kamailio configuration file. So this is my presentation about the combining the two type of interpreters that we have. I use it a lot lately in this combination. As I said, I'm going, or many customers prefer now KEMI, especially like Lua or JavaScript, because their team is somehow familiar with the language itself, and then they see Kamailio just as another library, and they need to learn some functions. But they know the structure, they know how to troubleshoot a little bit more. But for some things, I feel it's better to still do it in the native scripting, and I write some routing blocks and call them from Lua, or if the customer prefers JavaScript or Python, I do it the same. So I'm ready for the questions before starting the party a little bit later, but we can stay even later for having the fun.
Thank you, Daniel. It's always good to listen to you, and I think a lot of people have a lot to think about here as well. I agree with what you said on the last slide, that we're hoping for a Berlin edition next year. And it's always hard to be the last speaker before the party or dinner or lunch. But I have some questions for you. We had a discussion about Golang, but that's already answered. I wonder if we have a map of functions that aren't implemented for KEMI? Is there such a list automatically made somewhere if someone wants to contribute?
Unfortunately, we don't have it. Maybe we could look at extending. We have now a tool. It was a good contribution. Sorry, I don't remember the name right now, but if you look at the documentation for KEMI, should be listed at the top. That one parses the source code and creates the index for exported functions to KEMI. It's how I got these numbers with how many were exported, over 100, 1,000, 1,100, and so on. But we don't have the other way around of looking at exports to native scripting and trying to match with what we export to KEMI. I'm not sure how easy it would be because the tool is now in Python and I'm not the greatest Python developer, not even a good one, but may worth trying at some point. The usual way now it's discovering, and somehow we have the rule, if you discover an existing native scripting function missing, we implement it and we backport it, because this is actually no new features. If you look at the C code, it's practically splitting, or not even a need to split, because as I said, the native scripting has like two steps. First, it's evaluation of the variables to get like plain integer or plain string value, and then executing another function. And that function is actually executed by KEMI interpreter because it gets from Lua, from Python, directly integer or string values. So there is no new feature. Sometimes it's just straightforward to export it by a few lines of code. Sometimes a function needs to be split in two, because some of the function have this evaluation of the variables at the beginning and then continue with the integer string values from the variables and split in two. So the second part becomes the KEMI export directly.
Okay. So that's a task we may need help with, fighting the Python script to get the other side of the list.
Really appreciating it.
Yeah. There was, I think you mentioned it, but I failed to understand. When we're calling a KEMI function from the Kamailio config, or we're calling a Kamailio root block from KEMI, how are return values exchanged? You had an example there, but...
Yeah, so I can go back. Let me show it just to be easier. So way to exchange, and very convenient from performance point of view, it's using our what we call script variables. Oh, sorry. So you see on the left side, after sending the reply, I set the variable exit equal 1, $var exit equal 1. And in the right side, after execution of the KSR route, I check, or I retrieve the value with the KSR PVX var get. So this is from the PV module.
Yeah, but that's a bit sneaky. What happens if you add a return value after the keyword return on the left-hand side?
That should be returned as, so you can have on the right side local variable ret equal KSR route REMI headers, and we should propagate it. We do that for, I mentioned it before. So when something is returning 0, which in native interpreter it's like an exit.
Yep, that's the dangerous part.
Yeah, but you can check this in the configuration in the Lua script. If it was a return 0, then you do a new exit from the Lua. In this case, X exit. But like also in the native scripting language, you can get the return code of remove headers or trelay or SL send reply. They also return 1 usually if it's a success, or -1 or some other negative value on a failure. The functions again will expose the same return code, because if you execute on Lua like KSR SL send reply, you'll get the return code as it is in the native scripting for the corresponding function.
Especially T-relay has a lot of return codes that are important to watch out for.
Are the same. It's why if you look at these more complete examples for Lua Python, you have conditioning less than 0 or greater than 0, because we have in this native scripting interpreter this a little bit strange behavior. If it's negative, we evaluate it as a false. If it's positive, we evaluate it as a true. That we cannot propagate it to Lua and Python. You'll have to do explicit if it's less than 0 or greater than 0 to know it was an error processing or it was a successful processing.
Okay, I don't see any other questions from the audience. I think everyone wants to party.